pre-calculus, let's take a look at a lesson using synthetic division, okay, and PRZs. So we can divide polynomials using synthetic division when the divisor is linear with leading coefficient of 1. Okay, so what that means, for example, if we're dividing by something that's 1x to the first plus 7, okay, if we're dividing by a linear that has a 1 out in front, we can do synthetic division. Synthetic usually means fake. Okay, so what you do is you take the 0, and you put it in a little box right here, and then you write all the coefficients, okay, with oxes, okay, and here's how it works. You start by dropping the first one down. Okay, what's a 0? It could also be called an x-intercept, okay, or it could be called a root. For example, if I was dividing by x plus 7, okay, the number that I would put right here in the box would be a -7. Let's show you how one of these works so you understand what I'm talking about. Okay, we're going to use synthetic division, not long division for polynomials, but synthetic. Okay, we're going to divide this cubic polynomial by x plus 2. This works, okay, this is the divisor, and the divisor is linear. Okay, so in the box right here, the 0, or the x-intercept, would be -2. Okay, now we have to put all the coefficients with oxes. So if we start with a third power, we have to have a place for every power less than that, all the way down to the number. So 5 is for the x to the third. After the third power comes the second power. His coefficient is 3. The first power, and then sometimes I say the none power. Okay, so here's how this works. All right, step 1, we're going to drop down the 5. 5 times -2 is -10. And then you add these together to make -7. Then you multiply. Negative times negative makes positive. Then you add them together. Multiply, multiply, -32, and you add them together. Okay, now let's give this some meaning. Okay, so I divided that cubic by that linear. Okay, and what's my answer? First thing I'm going to do is put a little box right here, chunk this off. This is called the remainder. So I'm noticing immediately that this did not divide evenly. This was x to the third, okay? So my answer is going to be 1 degree less. 5x to the third got divided by an x. 1x came out, so this is going to be x to the second. 5x to the second minus 7x plus 16. Okay, and then I'll take that remainder, -31, and we always put the remainder over the divisor, which would be x plus 2. Okay, let's try synthetic division one more time. Okay, this one looks a lot more fun. It's really small, okay, but don't forget about the x's. When we have x minus 1, what number would go in that box right there? That's right, a positive 1. Okay, and now we have to say there's 1x to the 5th. There's 0x to the 4th. X to the 3rd. X squared. X's. Oh, and then there's the number, the constant -1. Let's just double check. X to the 5, to the 4, to the 3, to the 2, to the 1, to the none. Perfect. You have to have one of every column. Okay? We're going to put a bar like this. This is where the quotient's going to go, but here's the work in between for the dividing. Step 1 is to drop it down. Okay? 1 times 1 is 1. 1 plus 0 is 1. 1 times 1 is 1. Add them together, 1. 1 times 1 is 1. Add them together, 1. 1 times 1 is 1. Add them together, 1. 1 times 1 is 1. Oh, look at that. They canceled out. Okay, so there was no remainder. This one divided evenly. Okay, this is what we're going to really want to go for. Okay, if we want to divide evenly. The final answer. Okay, let's just remind everybody, this was x to the 5th. If you divide 1x out, his answer will be 1 less x, x to the 4th. 1x to the 4th plus 1x cubed plus there's 1x squared plus there's 1x plus 1. Okay, that one right there is always going to be the constant. Remainder, constant, then they go higher, higher. Okay. All right. Sometimes you might get asked a question like this. Is x minus 3 a factor? Okay, is it a factor? To be a factor, that means that it goes in evenly. It goes in evenly, okay? So I'm hoping, okay, for no remainder. That's what I'm hoping for, no remainder. Let's go see if that actually happens, okay? What number would go in the box? That's right, a positive 3, okay? Now don't forget about all your x's. 1x to the cubed, negative 4 for x squared, 0 for x, negative 5 for the constant. All right, step 1, we're going to drop it down. 1, 3 times 1 is 3. Add them together, negative 1. Multiply negative 3. Add them together, negative 9. Oh, okay. This is the remainder, okay? Is it a factor? No. X minus 3 is not a factor, okay? Because I got a remainder. All right. All right, let's go to the next page. Use synthetic division to determine if it's a factor, okay? So what we're going to try to do this chapter is get polynomials factored. And the way that we're going to do that is with synthetic division. So if it works, we're going to write the factor times the quotient. Okay, so let me just explain to you what that means. Okay, I'm going to ask you something like, is 2 a factor of 10? Okay, yes, 2 is a factor of 10 because I can take 10 and I can multiply two things. Okay, 2 times the other thing. How do we find the other thing? Well, I'll divide 10 by 2 and I'll get a 5. That's what we're going to do. We're going to divide. If it works, you're going to tell me the two things that make the problem. Okay, so is x minus 1 a factor? Let's see. I'm going to put 1 in the divide box. And then all of the coefficients with x's. 2 for the third power. Negative 1. Positive 2. Negative 3. Oh, I didn't need any x's. You guys know what an ox is? Okay, an ox is a 0x. It's a 0x. Like this one here, there are lots of 0x's. There's an ox. There's an ox. Okay. Step 1, drop it down. 2 times 1 is 2. Add it together, 1. 1 added together, 3. 1 times 3 is 3. Yes, it works. Okay, it's a factor. It's a factor, okay? As soon as you get something that works, you must write it in factored form. Okay, if it is, here we go. Okay, what is f of x equal to? Okay, well, I know that f of x was a cubic, but now I'm going to write him in factored form. Okay, x minus 1 was the factor. Okay, so here's the factor that we found. And then here is where you put the quotient. The quotient is the thing that you found after dividing. This problem started with the third power, so this is going to be 1 less. 2x squared plus x plus 3. Okay, so this is what we're doing this chapter. We're factoring with the help of synthetic division. I couldn't factor this by grouping. I couldn't factor the trinomial with an MA table, so we're going to factor with synthetic division. If your problem starts off as a cubic, okay, f of x was a cubic, so f of x down here, okay, look at this, is still a cubic. He still has a power of 3. We can't just write the quotient. F of x can't become a quadratic. He has to stay a cubic. If you start with a power of 3, you always have a power of 3. Okay? Let's try one more time. Use synthetic division to determine if x plus 4 is a factor. Okay, let's see if he's a factor. In the little box, I'm going to put -4 for the 0. Okay, let's be careful that we include all the x's. So we've got 1x to the 6th, but 0x to the 5th. -16 for the power of 4, 0 for the power of 3. 1x squared, 0 for the linear term, -16. Okay, lots of x's in that one. Constant to the 1st, to the 2nd, to the 3, to the 4, to the 5, to the 6. Got them. I got them all. You have to have one of every column. Okay. Step 1, drop it down. Multiply -4 times 1. Add them together. Multiply negative times negative makes positive. Add them together. 4 times 0 is 0. Add them together. 4 times 0 is 0. Get a 1. -4 times 1 is -4. Add them together. Negative times negative is positive. And look at that. The remainder is 0. So is it a factor? Yes. Yes, it certainly is a factor. Okay. If it is, we must immediately stop and write this down in factored form. Okay. So I'm going to write f of x a different way. F of x was a 6th degree polynomial. A 6th degree. My answer down here still has to be a 6th degree. The factor that I found was x plus 4, okay? And then the quotient, if this was a 6th, this must be a 5th. X to the 5th minus 4x to the 4. X to the 3rd, there is none, so I'm not going to write it. To the 3rd, to the 2nd, plus x minus 4. Okay, there we go. I wrote f of x in factored form. He started as a 6th, and look at this. X times, if this is still a 6th degree. Okay, now eventually where we're going to go with this is I'm going to say keep going, factor more, factor more. Okay, now some people ask, how do I know what numbers to try? Okay, I'm going to be here all day if I just keep trying. Okay, so how do we know what factors to try? Okay. There's things that are called possible rational zeros. There's possible rational zeros, okay? How do I know which ones we'll try? Not all numbers will work. Okay, well that's great. How do I know which ones might work? Okay, might work. When it says possible, okay, this is not all of them, but these are the only ones that might possibly work. Okay, so PRZs are found by doing two things, okay? In the numerator of a fraction, you have to do plus and minus all the factors of the constant. All the factors of the constant. Where's the constant term? Okay, it's the last term. It's the last term. Okay. And then in the denominator, you have to do plus and minus the factors of the leading coefficient. The leading coefficient. Okay, where do I find the leading coefficient? Well, it's the first term in the polynomial. Okay, and then here comes the important thing, okay? You must make all combinations. What? All the possible combinations? Okay, so here's an example, and I'm going to show you how to make a list. This is a list of numbers that might work. Okay, so when I say, try to get this factored, and you say, well, what number should I try? We're going to pick them off of this list. Okay, so here's how you do the PRZs. Okay, in the numerator, you have to do the factors of the constant. Okay, so that's 10. So what numbers go into 10? Plus and minus 1, plus and minus 2, plus and minus 5, plus and minus 10. Now the denominator, okay? The denominator is the leading coefficient. The leading coefficient for us is a 5. What are the factors of 5? Well, 1 can go into 5. We always start with 1. And then 5 can go into 5. Okay? But now we have to make all the possible combinations, okay? So now we have to put all these numerators with all these denominators. Let's start with 1. Okay, that's easy. Let's divide all of them by 1. 1 divided by 1 plus or minus 1. 2 divided by 1. Okay, put 5 over 1. That's plus and minus 5, comma, plus and minus 10. Okay, I've taken every possible combination with the 1. Okay, 1, you're done. Now I have to divide all of them by a 5. 1 divided by 5 is 1/5. 2 divided by 5 is 2/5. 5 divided by 5 is 1. I already have 1 in my list. I'm not going to write it again. 10 divided by 5 is 2. Okay, so here's the list. Okay, this is a list of factors that they might possibly work. They might possibly work. If you were going to start trying numbers, should you try the number 3? No, 3 is definitely not going to work. These are the only ones that might. I notice he's a degree of 4. Are all of them going to work? Certainly not. This is way too many. But these are the only ones that might work. Okay, so I would try 1, then try -1, then try 2, and try -2. Okay, try. This chapter is going to be so fun. Okay, it's not for the faint of heart. You have to be really brave in trying numbers. Okay, last one. Let's list the possible rational zeros. Let's list the PRZs. Okay, the PRZs are, okay, write a fraction bar. We're going to start with 6. So plus minus 1 goes into 6. 2 goes into 6. 3 and 6. 6 times 1, 2 times 3. Okay, now for the denominator, what goes into 2? Well, 1 always works, and then we have 2. Okay, so now we have to make all the combinations. Okay, let's start with the 1. Divide them all by 1, and we have plus minus 1, 2, 3, and 6. Okay, now it's time to divide them all by 2. 1 divided by 2 is going to be 1/2, plus or minus. 2 divided by 2 is 1. I got it. 3 divided by 2 is the fraction 3/2. 6 divided by 2 is 3. I already have it. Okay, these are the PRZs. These are the possible rational zeros. Okay, so what did you have to learn today? Okay, can you use synthetic division to divide a polynomial? Okay, I hope so. I can use the remainder theorem. Okay, so what we're going to do for this is do synthetic division. Okay, and we always look at this last number right here. Okay, and this will tell you what the remainder is. I can write a polynomial in factored form. Okay, when do you do this? Okay, you only do this when the remainder is 0. Then you write it in factored form. If it didn't work, don't write it. Try another number. Okay, I can make a list of PRZs, the list of numbers that might possibly work. That's going to give you a list of things to try. Okay, and then we're going to use synthetic to test our list to see which ones are. If it doesn't work, throw it in the garbage. If it does work, you found a winner. Great job, pre-calc.